Susama, welcome.
So let me start by just, her introduction is there. She is a principal scientist, Dr. Susama Sudishri, principal scientist at ICAR, and I have already shared her bio with all of you. So without much time, spent on her bio, which is I cannot. I mean, it's a very glaring bio. Let me request Susama to speak for half an hour, and then we can engage with her for another half an hour. Okay, Susama, all yours.
Thank you, sir. Respected my seniors and all my teachers, my juniors and my friends. I am very much thankful to Devasmita sir, who gave me this opportunity, the whole team who is organizing this tea talk. Actually, it has been, I gave this topic as just a few days back. It was lots of discussion on this dam restoration and it's what are the different problems and how to restore it. As agriculture engineer, what is your role and how can do it. So without going in detail about what are the different types of dams and all those things everyone knows, so I will go directly and I will emphasize more on what are the different problems and what are the different reasons of failures. So those things I will discuss. Sir, it is visible?
Yes, yes.
Yes, it is visible, but you have to put it on
Slide show mode.
Slide play mode.
Now it is okay?
Yes, it is.
Yes, yes.
Yeah. So as you know already, that generally dams are nothing but the massive barriers across the river or any streams. And why it is built up, that is there are the four things we'll have to look at. What is the first is the storage. To store across the river so that there is some head will create in the upstream and it will create some storage to generate electricity and to supply water for agriculture, industry or household and to control flooding as well as to navigate in a river, and that is not our purview as agriculture engineer, but main thing is to supply water for agriculture and how to control flooding. So these are the main things what we are doing as agriculture engineer. So if we'll see in general, what are the different components? So as we have studied also in BTech and what are the different components of a storage structure, you can see the first is the storage, and from the catchment water is flowing to the storage area, and these are the crest barrier, and then is the emergency spillway as well as the mechanical spillway. Through which water will flow for irrigation. So there is this, and upstream slope and downstream slope. All these things we'll have to look into when we are doing the design. But if you see here, what are the main reasons of failure? So that thing we'll have to look into and we'll have to discuss more and how to tackle all those problems. That is the main thing what I will give the emphasis here. So if you see generally, suppose if you go for any concrete dam or any masonry dam or any earthen dam, it is more problem in case of earthen dam. If there is a trees or bushes and all those things that will create the problem on the crest and the upstream and downstream slope. As well as there is the problem of cracking that may be due to the settlement or maybe the inadequate material used in case of concrete or the gravity dam, or in case of if there is a seismic activity or that is your earthquake. So these are the reasons of cracking on the dam. And there may be settlement in crest of dam, wave erosion due to the wind velocity or sometimes more storage in the upstream. And there may be debris problem at the inlet. Due to which there is the problem of internal erosion and leakage of conduit. So these are the some of the reasons of failure of the these dams. And if we listed it out, the problems, what are the causes of failure? First is overtopping. This is the main cause of failure of any dam, the overtopping. As we know, the climate change, due to climate change, the intensity of rainfall is increasing. So there is the possibility of overtopping. Whatever the intensity of due to intensity of irrigation, so that is the main problem of overtopping. And there may be the water breaching or foundation of dam may be inadequate. And there is the another main cause is the piping. And the subsistence and movement of the foundation and due to uplift pressure, there is the problem and the sliding of the structure. So whatever the list you are seeing, the main problem is overtopping. What I have seen in most of the dams also. This is the reason. Another is what we have discussed just few days back about the seismic load action, that is earthquake. So I will discuss something about all these problems in in next slides. Here I have listed some of the 112 dams all over the world. Those what I have listed in my previous slide. So these are the reasons of failures of these dams. If you see, there are total 112 dams I have listed. There are so many other dams. These are the major dams all over the world which are facing those problems, one and other. So these are the list of some of the dams. I am not go in detail about all these dams, but these are the reasons of failures. See. But if we come to India, in India, there are 5,264 large dams, which stands the third position after China and the USA. And this structure not only create the irrigation potential, but also cater the human need in whatever the way, and also is the power generation. So if you see the age of dams in India, so most of the dams are more than 50 years. So there is the problem of its stability of dam when we are talking about the climate change or earthquake. So that thing we'll have to look into now for this for sustenance or restoration of these dams. And these are the challenge that I will show. What are the different challenges that we are facing now for its restoration? If you see the dam failure and this large dam failure, if you see the Rajasthan, in Rajasthan, the number of large dam failure is more compared to other state. And if you see the year-wise dam failures, 1951 to 1960, during that it was more. But gradually, if you see the 2001 to 2010 also, there is the more number of dam failure. There is no, and what are the reasons? If you see here, breaching of failure due to flooding in some of the dams, that is 44% highest, and followed by overtopping. What I have already shown, these are the main reasons of failure of dams. And these are the larger dam under construction in India. Mostly more number of large dam is under construction in Maharashtra, followed by other states, that is Andhra Pradesh, and if you can see here what are the other states under construction or large dam. But the most important is, if you see, 11 dams showing storage less than 50%. So that means sedimentation is the main problem, due to which the storage capacity is reduced. That is more than 50% reduction in the storage capacity. If you see the data in this India. So all dams showing the trend of less current storage compared to last year's storage, so 10 years average storage, whatever you take, that is the reduction of the storage capacity in all over. Now you come to India, what are the different major dams? First, if you see the highest dam, that is the Tehri Dam. Just a few days back, I got the opportunity to visit this Tehri Dam. And this is a very good dam. Anyone I can suggest to visit first. But the most problem is the sediment deposition. And another is the longest dam, Hirakud Dam, and everyone knows about the Hirakud Dam problems. And some of these large dam, major dams in India, they are facing what I have listed out the problems for these dams. Now come to these are some of the in detail, but I am not going to read. Just see the Hirakud Dam and the shapes and structures for different uh, purposes they have constructed. But now they are facing the problem, and if you will not take care about these dams, then in the future there may be they will create the havoc in the downstream side. So these are some of the major dams in India. Now come to the government, what they are doing. The Central Water Commission, now they are monitoring the live storage capacity of the dam, most of the dams. Now out of these reservoirs, 20 reservoirs, their projects and live storage capacity, it was like this. But it is estimated to more than 50%, what I have shown earlier slide, the live storage has been reduced. If you see, this is the Times of India. It has been published during September 23rd, 2023. It has been shown that in Upper Kolab Reservoir in Odisha, the water level has been decreased. So what may be the reason? There are two reasons. What are the reasons? One is there is a decrease in rainfall, one side, and another is there is sedimentation. So these are the two problems due to which the water level in the Kolab Reservoir is decreasing. That this has been published in Times of India, September 23rd, 2023, just recently. Now these you can see earlier how much
Susama, are you frozen?
Yeah, it is not audible.
Susama? Okay, she has some internet problem, I think. Oh.
Yeah.
Devbhai, maybe some of us, we have to give a call to her. Maybe she doesn't know about it.
She just WhatsApped me saying that I'm having some problem, I'm rejoining. So she will be back. Just give her a second. Looks like her internet is working fine now. I don't know what is happening at her end. Okay, she is back. She is back.
sorry, sir, there is some problem. Okay.
Yeah. Okay. You can restart from the.
Just I am sharing.
Okay.
Yes. Sorry, there are some technical problem.
You need to go back a few slides because you were on a different dam. No, yes, you were. No, just after this one.
Yeah.
Okay.
Sir, what I was telling about this, the reasons of decrease of water level in Kolab Dam, that is the less rainfall, what they have shown by this Mr. Sunil Biswal in Koraput, environmentalist, and the sedimentation problem. So there are two reasons why it is decreasing day by day. So what are the differentials? Here I can see, so everyone knows about the Damodar Valley Corporation, DVC, Hazaribagh. So at that time, there are different dams, that is reservoirs were created. But the main problem why it has been not functioning, that is due to the siltation. So that is the main problem. If you can see, it has been constructed in 1955, 56, 53, 55. But the rate of silting, you will see here, million cubic meter per year. Due to this, the capacity has been reduced by 23 to 43%. So you can imagine the main problem is due to the sedimentation. Similarly, if you see the Hirakud Dam also, the similar problem. But if you see the sediment, the question is how to reduce the sediment, but whatever it is already there. So if you see the Hirakud Dam, it will take about 4 to 5 years if you want to remove the sediment from the Hirakud Dam. So it is a very difficult challenge to how to do that. So, but one time it has to be done. First, we will have to dry up the reservoir. It is not easy task at all for doing this job. So similarly, if we will go to Tehri Dam, the main three reasons here it is what we are talking just few days back about the reservoir induced seismicity. So till date, it is withstanding up to already withstand up to the magnitude of 8. But when just 1 week before I visited the Tehri Dam, the officer of the Tehri Dam told it can withstand only up to 10. If there is the magnitude of any earthquake more than 10, then there will be a great havoc in whole Uttarakhand and UP, even it can up to Delhi. So that much loss we can, that much problem we can face if there will be a problem in Tehri Dam. If the magnitude of earthquake is more than 10. Similarly, these are the causes. You can see there is a foundation problem, 40%, inadequate spillway, 23%, poor construction like this, 12. If you listen the earthquake, it is only less than 1%. But this 1% may create a great problem if the necessary action will not be, or necessary forecasting or if anything that is evacuation or other thing, it will not take care by the government. So these are the important earthquake already happened in this. You can see the Himalayan frontal already some of the earthquake it is occurring, but it will be more than that. Then there will be a problem for the dams that is in this region. Similarly, in peninsular region. So these are the magnitude it is occurring. But if it will be more than 10, then there will be a great problem for the dams in this situated in this area. So there is a need of this dam renovation. But how to do that? That government is taking care now. There it is a DREAP project. It is going on. Dam rehabilitation and improvement project for which government has already been sanctioned 2,100 crore for this renovation and this dam restoration. And there is a Dam Safety Act already in 2021, government has been implemented for its surveillance, inspection, operation and maintenance. So this is a good thing that government has already been implemented this Dam Safety Act. So now you can see similarly for all over world, there are some dam I have shown here that has been rehabilitation work is already done before. Is you can see in 67 it is the California. Devasmita sir, you can say better about this who are from USA. They can see say better all this dam. What is renovation already? Some of the dams renovation already been done. So we'll have to see how they are doing and how it can be done for our India. So these are the some of the dams that is in Switzerland, Spain, USA. So this is in China. The most problematic reservoir in Yellow River. That if you will search any paper, research paper, in every journal, one paper must be from Yellow River reservoirs. So that is the most important. That is the famous river, Yellow River. The reservoir, whatever the reservoirs are there are so many problems in this. But they are doing the rehabilitation work or renovation work in this reservoir also. So these are the some of the dams. They are doing the renovation work. Now the question is, my topic is regarding your circular economy. What are the different problems? How to do the circular economy? How it is linkage of circular economy with this dam? So that thing I will just tell about some slide in next slide. But the most important in water bodies or dam is physical, chemical, and biological pressures. So what are these physical, chemical, and biological pressures? Physical pressure means if you see the temperature, hydro period, and climate change. Hydro period means suppose somewhere some flood or some drought. So due to temperature difference, so there may be this problem in case in dams or any reservoir or water bodies. Then sedimentation and soil erosion. These are the whatever the list. If you can see the India, there is the soil erosion about 16.35 tons per hectare per year. And there is a 10% deposits in the reservoirs. That data is everyone knows about it. But here what I am emphasizing, this is the physical pressure in the dam. Similarly, if you go to chemical pressure, that is a nutrient loading or eutrophication, and there is a road of runoff, unmanaged disposal, about the municipal wastewater and other thing. Then other inadequate policies managed and planned. If, for example, in Uttarakhand province, there is the built-up area increased in the water bodies 15%, led to reduction in the pond surface area. So there are other things I can say what I have done in this Delhi or this area. I will show these some of the things how we can do this renovation work. So what are the different strategies for pond restoration and management and conservation? That is a long list, but you can see the first is a government policy and financial incentive. What government is doing now also. The second is inventorying and monitoring. So this is the important thing to remote sensing and GIS. So that is work is also going on. Then hydro period modification, erosion control. What I have told, the flooding and this drought situation, we'll have to tackle so that this problem we can avoid. Then about this nature-based solution of pollution control. So that is your deforestation, vegetative buffer strip, constructed wetland. So these are the some of the things that we can do for this restoration work. Suppose somewhere some problem, wastewater it is flowing to the reservoirs or water bodies. So in that case, this nature-based solution, that is engineered wetland or other thing, that or phytoremediation. So those things we can do. So when it has been done, so these are the some of the ecosystem services, that is provisioning services, regulating services, and then cultural services, and these hydrological services. All these things when it is leading to your circular economy. That is the reason is natural capital, keep resources in use. That I will in the next slide I will say detail, and reduce the waste. So these are the things what will lead towards your economy part, and which will lead to attain the sustainable development targets, that is 2, 6, 13, 14, and 15. So again, when it is target fulfilled, then again it will go to the government policy and financial incentive. So if you see here under Jal Shakti, Ministry of Jal Shakti, that is 240 billion that has been also sanctioned for doing all these works. Now come to what is this circular economy. So that presents a window of opportunities to not just address the existing resource constraints, but also drive transformative benefits for business and consumers. But how it is linked to dam? So because what we are talking about, the water storage and whatever the storage, we are talking about the fishery and other bioparticles, that I can say the plants and other thing and the waste material. So all those things will have to reduce. Somewhere we'll have to reuse, somewhere we'll have to recycle or reclaim, recover and restore. So these are the 6 R of the principle of this circular economy. So linking all these circular economy and aquatic ecosystem with this water, food, nutrient, energy, that is your biomass, biofuel, and the what I have listed earlier, the ecosystem services. So all these things we'll have to look into for all over, all around this benefit of the taking the benefit of these dams and reservoirs. So you can see here. So in a diagrammatical form, this is the circular economy with the pond system or dam and water body system. This is the agriculture, industry and household. There's the use and how to do say energy, biomass, then pond ecosystem, biodiversity, then water or food and nutrients. All over the things it is there. We can link to get more circular that economy. In detail, it is there. So if I will go one by one, so I may not meet the time. So we can discuss when during the this period. So what are that? So in total, a restored and well-managed pond directly or indirectly, the 3 C principle, though it is 6, but overall there is 3. Regenerative natural capital, that we will have to look into the biodiversity, its water cycle or nutrient cycle, and the most important is water quality. Then keep resources in use, that enhance resource use efficiency, and design out waste externalities, that is reducing the environmental impact as well as the waste material what is flowing to the dams and the reservoirs. So those things we'll have to look into through this circular economy. So the main challenge for renovation or restoration of dam is the involvement of different ministries. The most important is the involvement of different ministries. So there is no convergence and linkages among the ministries. So this is the main challenge to do all these things in a proper way. So I will say what are the different problems we are facing. This is the problem in what we are facing, doing the work. Now I am taking this project also in in-situ of Delhi. The Wetland Authority of Delhi and Delhi Development Authority, they are looking after under their different water bodies. But how to restore all those things? Though government is emphasizing on Amrit Sarovar or this Jal Shakti under this Ministry of Jal Shakti Abhiyan, but there is the challenge. You can see main problem is how many water bodies located is available and how many it is not functioning. So all those things for first we'll have to develop the inventory. So those things we have done for in-situ of Delhi, but it is not matching what is available in state government. So this is the main challenge, what we are doing and what they are telling and what we are doing. So that has to be, there is some convergence approach and linkages should be done for meet out this problem. So these are the some of the work I am doing for in-situ of Delhi. There are total 488 water bodies in in-situ of Delhi, and we are doing the what are the different water availability and all those things. So that is the work is going on. Similarly, the main another problem is site suitability, where it is, although it is there, but how will I find out the site suitable of subsurface dam? That work also I am doing in Sivaliki Hill of Himalaya. So what are the different strategies we are doing through different techniques? So about climate, hydrogeology, geology, socio-economic parameters, or through remote sensing and GIS and multi-criteria decision-making tools. So those things I am applying, and we have these are the thematic maps we have developed, and these are the potential sites we have found in Sivaliki Hill, where the subsurface dams we can develop. So why I have shown here? Here you can see the fault map, this third one, because we'll have to see the fault where it is there, so that there from the at some distance we'll have to construct the dam. So those things we'll have to look into when we are finding the location for constructing of any dam. So these are the techniques we are doing. Similarly, I have taken the site suitable of different water bodies or ponds in Mewat, Haryana. So those similar things also we have done, different map, hydrologic zonation map we have developed. And once the hydrologic zonation map developed, then we have found through different multi-criteria decision making tool. So where the water harvesting structures or ponds to be located, where it was, and how many water harvesting structures we can locate. So those things also we have done. And after that, just we have done the renovation work. And here I can emphasize, just the government is giving the money to the state government on in Narega people. But they do not know, we only agriculture engineer can do that. The problem is they do not know how much to do the siltation work. Just they are taking or through manually or through JC machine, they are doing and they are digging and just they are taking the money. That's all. But they do not know scientifically how to renovate a simple water body. So that part we have done, what is the strategy and what is the procedure to do the renovation work, what the government is emphasizing for Amrit Sarovar program. So here I can say for dam restoration or reservoir restoration, the main is the siltation, what I have told. So we'll have to look into the catchment treatment. And Dr. Dikedas sir also in earlier, he has shown something about these things. But here I can show how we can do the catchment treatment, that I am going to show here what I work for Upper Kolab Reservoir. And also here, what I have developed the technologies that I want to show here, so that other my seniors or juniors, they can learn from this, what are the techniques we'll have to take into. So these are the simple things. You can see here, there are three, in catchment, there are three slopes: upper slope, medium slope, and lower slope. So if you go to upper slope, there is the only, it is dependent on the rainfall, no other source. So here, how to big problem is the, since you can see this is the upper in the catchment of Upper Kolab Reservoir. This is denoted. So we have developed this like this. Different in-situ water conservation practice, that is a micro catchment like this. We have planted the mango plant, and this is the hortipasture. This is the plant for this cashew and stylo. This is the nutrient rich. So it will enhance the soil health as well as reduce the splash erosion here itself. So these are these things we can do in the catchment of a reservoir, so that to reduce the siltation. Like this, there are different in-situ water conservation practices we can do with agroforestry system, horti-silvipasture or hortipasture or horti-agri. So whatever the land capability that we can do in this area. So these are this is the of northeast. These are the different in-situ water conservation practice that can be done. Now come to medium land. On medium land, farmer wants not only the soil erosion to be reduced, but also they want the fuel load as well as the this crop yield can be increased. So for these type of things we can do across the slope. And you can here you can see the LBCD, loose boulder check dam, simple in small gully. You can see the upstream, there are lots of vegetation. Why? Because when there is a reduction in sediment, in the upstream deposition of sediment, so automatically this planting vegetation, it has been generated. So these are the some of the medium land that we can do. In non-arable land, these type of things we can do for reducing the and these are the some of the agronomical measures. This is the stone bond, the other crop diversification that can be done to reduce the, and these are the some of the drainage vegetative barrier. So that these things we have done in Odisha. Now these are also we have done in different drainage line treatment for reduction. And here it is in semi-arid climate. different agroforest system with in-situ water conservation practices and different crops. You can see different in-situ water conservation practices and different crops. So in this way, we can do in the catchment of this reservoirs. So now these are the different in-situ water conservation. You can see the crop and also water conservation practices. So these things I have done here in Delhi as well as Rajasthan and Haryana here. So these are the some of the techniques that can be implemented. Now these are also in the here also IRI, these things we have done. But the most important when we are doing the catchment and command area ratio. Regarding command area, Dikedas sir told a lot in previous data. So I am not going to tell all those things. But there is must some catchment and command area ratio. So we should follow. So these are the some of the dams and reservoirs that has been constructed under in ICR through different programs. So these are these things I can say it is in Odisha what I have done during that period. The Arden Dam, dugout pond, spring pond. But one thing is Jhola Kundi. This name has been given by me. On lots of the perennial source of water. So in adjacent to that, we have developed like this. So earlier the farmer could not take any crop. So they can throw using this Krisak Bandhu pump. So they are using this and they are taking the vegetables and other remunerative crop. And these are the compartmental type of dam or structure we have created, and they are irrigating through this underground pipeline system. So these are the different water bodies, and these are the common, you will have to link to different, and these are multiple uses of harvested water, so that our economy can enhanced by the to the farmers. This is the crop diversification, and this the renovation work also we have done in Mewat of this Haryana, and the utilization part through this micro irrigation system. So those things we have also doing here, and the dissemination through this to the farmers also. So my last slide is, so success of water bodies or dams depends on use of every drop water, people's participation, training for its acceptability, formation of water society and other linkages and convergence is the most important, and for this success of these dams and reservoirs. Thank you, sir.
Wonderful. Dr. Sudhishri, this was a great discussion. So we'll now open it up for engagement. Any questions or any comments, or if you want some clarification, please either put it in the chat, or you can just unmute yourself and ask Dr. Sudhishri or ask anybody else in the group.
Okay, I have a question to Dr. Sudhishri, myself, Dr. D.K. Das. What are the criteria? You have taken a tool of multi-criteria decision making for some development works of the dams and water bodies. What are those criteria? And what about circular economic that you are getting it? And another one is what are the techniques you are using to reclaim the water bodies other than taking out silts, reclamation process techniques that you told agri-engineers can do it. So it will be, if it will be highlighted, it will be very much useful. Thank you. And very nice presentation by Dr. Susama Sudishri. Thanks for that. Okay.
Thank you, sir. And sir, before I answering your questions, first, I think you do not recognize me, sir. You have trained me 11 months at Valmi during 95-96. So during that period, you were at Valmi. So Canal Command area under CADA when I was there. So you trained me a lot, sir.
Thank you very much.
I remembered you, sir. Sir, about this criteria, that under this multi-criteria technique. So under that, we have taken different, you will see the design of water bodies. So first is the what is the site? So that is the most important. So the criteria is your slope, drainage density, that is the geomorphological characteristics, and then your sir about the soil characteristics. What is the texture? And what is the sir about this? We have taken the ASP, analytical hierarchical process. We have given the different weightages to different these parameters. So not only this, what is the distance of this water body from settlement, because it has to be used for irrigation. So what is the elevation point and the slope, drainage density, and then your distance from the settlement and soil characteristics and geology. So all these are the some of the things that we have considered for selection of the site of this water harvesting structure. Another thing about sir, what you talked about this circular water economy. Sorry, circular economy. Sir, circular economy is the vast subject. All the what are the different techniques we are discussing, everything we cannot attain in from one work. Because for example, suppose simple, we are having the dam or reservoir, or any simple, sir, suppose a pond. So from pond, so how much is the runoff water availability, and how much is the sediment or soil loss it is coming, it is flowing to the reservoir or pond. And then what is the aquatic system, or suppose simple fishery. Suppose from fishery, how much money you are getting, or suppose big dam, how much recreation you have created. And suppose you are using the water for irrigation, so how much, what are the different crop diversification you are taking? Due to that, before and after, what is the difference you are getting? So all those things we will have to consider, sir, for this circular economy. And then it will go, suppose for example, how it becomes the circular then? Because once we are getting the, suppose for example, sedimentation. So if we'll do something in the catchment, so there will be less sediment, and then more area under can cover under command area. So in this way, there will be circular system in this reservoir. So, but we have done, sir, not complete whole circular economy what we are talking, that I am doing, not completed. So those things, sir, we'll have to do in detail.
Okay, thank you. Another one is that about this reclamation process.
Sir, regarding reclamation process, what I have told, sir, first is suppose said if we talk about sedimentation. I have seen, sir, in Haryana, UP, and even sir, Rajasthan, they are doing the siltation work. Okay, what simply they are doing? Simply they will take the JC machine. If under MNREGA, then they will use the manual labor, and they will do the siltation. But problem is, the question is, suppose you have sir, one pond, how much will have to dig, or how much will have to do the siltation? How will know? The question is. Suppose I want the answer from the audience also. So how will know how much will have to dig? If anyone can say.
Okay. That is for Dr. That is for Dr. Deepak Das to answer.
Nice, sir. Just I am interacting, sir. I will say the answer. Sir, question is, sir, sir, ଆପଣ କୁହନ୍ତୁ, sir.
No. That you told, that you can make a balance how much we can reclaim, but that is a process of using some mechanism to
Yes,
some dredging system or something like that. But
yes,
is there any other? Is there any other thing?
Sir, what? Suppose, sir, it is dried, okay, and there are lots of siltation. So we'll have to dig it. So what is the problem is? So nobody is doing the soil profile study. Okay, nobody is doing the soil profile study before siltation, desiltation. So what is the, sir, problem kon hoji na, sir? प्रोब्लेम होची कि सर जेतेबेले हमर पानीटा रहिबो सर किछिटा तो सर लेयर जदि हमर सैंड लेयर आसी गला ताले कोन हो सर पानी रहिबनी सपोज हम डिग कर देले so what will happen water will not store there so when first we will have to suppose there is a siltation up to what point we will have to decide first we will have to do the soil profile study what are different layers what are the soil texture. So before it is sand layer Asya Purvuru, so that up to that point only we'll have to do. Otherwise, there will after siltation there will be no storage. Sir, बहुत सारे लोक भी सेटा कंप्लेन करूछंदी जे गवर्नमेंट तरफरु हमर हेई सरला परे सेमान आसी के हमर डिसिल्टिंग कले हमर बे पानी रहउनी. So this is the main problem. We are not thinking about up to what depth we will have to dig.
Susama, I see a problem with your with the approach, and the problem is this: that first of all, drying the reservoir is not an easy job for a large reservoir. Okay.
Yes.
You are talking about smaller structures like a pond or soil conservation structures where we can dry it successfully. But Hirakud Dam, drying the Hirakud Dam, where are you going to place the water? Downstreams? That will cause flooding, right?
Yes. Yes.
So that is number one problem. Number two is even if you go down to the sand layer, how will you go down to the sand layer? I mean, with so much silt at the top, digging is expensive, okay, and it's not uniform always. Silt settles in a certain pattern, and sand is upstream. Sand is not in the downstream, correct, of the reservoir. It's always settles in the upstream. So we have to look at those issues also. But what you have shown here is a very important thing, and I want to emphasize that is how do we restore the upstream of the catchment. And that brings us to another question somebody has asked me privately, and I don't know why they didn't ask on the chat. His name is Hari Kumar Konda, and he's asking what is the ratio of catchment and command area of a dam or a reservoir. Can you answer that question quickly before we go into the discussion?
Okay, catchment and command area ratio, that depends on the what is the storage, how much to store in the upstream of the dam. So first is what is the catchment, how much to store here. So according to catchment we cannot change, okay, but command area according to that how much is the storage and how much crop according to the water availability and what type of crop you are going to take. Okay, so what is the water requirement of the crop and what is the storage available with that. So you'll have to see about the how much to be area, how much area can be irrigated. So that thing, but it is around 0.6 or 0.7.
No, his question was what does that mean?
Catchment command area ratio.
Right.
Yes,
his question was what does that mean? So it is basically what can be stored and how much area it can feed. Okay, yes. So that's the ratio. I just wanted to make it abrupt. But any other questions? Sorry, I didn't finish with my problem that I was discussing, but I want to open it up to others because yes, go ahead, please. Yes, we can hear you.
Hello. Good evening.
Good evening.
Do you hear? Hello.
Yes,
we can. Good evening to all. Myself, Durjodhan Nayak. Hello. Am I audible?
Yes.
Myself, Durjodhan Nayak. I want to speak something. Recently, I have retired. I have a little experience particularly in soil conservation and dam construction. As you told, what is the ratio of catchment area and command area? Actually, there are so many parameters as Dr. Susama told. There are so many parameters. We know all, but on an average, we can say that is maximum. We can in 10:1. Suppose catchment area is 10 hectares, we can maximum command 1 hectare. That is the approximate method so far we have adopted. Number 2, regarding desiltation. As our Dr. Debasmita told, he is correct. We cannot actually empty one reservoir, but there are so many options we have. So many options. Suppose during even high flood, we can evacuate some silts by making turbulence in the reservoir. In that way also we can evacuate. So modern technology, we will have to adopt latest technologies so that we can reduce the silt in the reservoir. And number two is most important. Only taking soil conservation measures, siltation cannot be checked. We will have to think for other options also. Suppose I will recommend, from my practical experience, as I know, suppose we have hilly tracts. Suppose one dam having some small hills in his catchment area, and we can make some drills so that runoff, the precipitation can directly enter into the ground. I mean, in India, we know that on an average, 40% water is going wastage through surface runoff. So our ambition should be that at least we'll have to reduce that. If you reduce the surface runoff, ultimately we are going to reduce the siltation also. So from the top of the catchment, if you take such steps, so siltation problem in major reservoirs can be reduced significantly. This is my suggestion. Just what you are taking research work, Susama. I'm very much happy to see you in this position. I congratulate you. If you are doing research work, you also look into that. How much steps have been taken in India regarding treatment of hilltops for harvesting groundwater.
Yes, sir.
Okay, thank you.
Thank you, sir. But what I have shown you, na, sir, that is the catchment treatment of the Upper Kollab Reservoir. And also we did the catchment treatment, sir, in Uttarakhand also, and also in Shivalig Hill also, sir. So what is your suggestion? Those are very good suggestions. Only we'll have to do in that process, so that we can reduce the sedimentation. So that is the main problem, sir, to reduce the main solution to reduce the sedimentation. Yes, sir, what I have already shown for Hirakud Dam, it will take, suppose only siltation, desiltation, it will take minimum, sir, I have shown in one of my slide, it will take minimum 4 to 5 years. But again, the problem is where to divert those water. That is also main problem in case of large dams. So, but the main solution we can, sir, further it will not aggravate. So the main solution is the catchment treatment.
Okay, Durjadhan, thank you. We have another question from Professor Satyanand Swai. What is the total area covered under WHS, water harvesting structures? And what is the total number of beneficiaries under in-situ small water harvesting structures? And Durjadhan will come back to you. Okay.
Sir, this question now in 2022, the Ministry of Jal Shakti, they have published the status of water bodies. So exact, sir, for I am not remembered, but already it is there, sir. For whole India, what are the how many water bodies are there? How many dams are there? How many small water harvesting structures are there? Sir, it has been published in 2022. Just I have seen, but I am not remembered. So to exact figure I cannot give now, sir. But if you can Google, sir, no? Minister of Jal Shakti, this water body status. So you immediately will get the PDF, sir. For I have not remembered, sir. It is already published.
Professor Swai, anything to follow up? Oh, okay. Durjadhan,
can I ask some questions, sir?
Yes, Kalpana, go ahead.
Okay, Dr. Susama, it is exactly not a question, just a curiosity to assess or maybe to have some estimation. That Jhola Kundi you said you have developed now. What is the size of that Jhola kundi and I mean width of that that pond or whatever what we could see, and what is the amount of crop area that could be developed? Like if there is any generalization, then we can know. Otherwise, the particular one what you have shown, that I would just like to know. It is just for my knowledge.
Yes, ma'am. Actually, ma'am, it is in Koraput district where the Jhola lands. That means always 24 hours perennial source of water. Okay. So farmers are not used to for only the Jhola land and the medium land. The elevation difference is only 1 to 1.5 meter. Okay. But farmer, though 24 hours of water is flowing, but farmers are not using that water due to this elevation difference. So simply what I did in the adjacent to the Jhola kundi, Jhola land. So I have constructed 3 meter dia. Okay. 3 meter dia and 4 meter depth. 3 meter dia and 4 meter depth. And this 4 meter depth varies. Suppose if you go to the upper slope, Jhola land, it is emerges from the foothill of the eastern ghat. Okay. So from that, when it is flowing gradually towards the downstream area, so this diameter is 3 meter, but the depth varies from 2 to 4 meter. And it is irrigated area, you can irrigate about 2 to 3 hectares. But yes, again that depends on the type of crop you are taking. Suppose more water requirement crop or less water requirement crop.
Accordingly that will be changed.
Yes, ma'am. Just when I developed now so many people are doing the Jhola kundi in that area, and Sanjay sir has seen when he was at KBK, so he has seen all those Jhola kundi and all those things.
Actually, why
Yes,
I asked is
true.
in my childhood, I have seen such type of structures people use and downstream for their personal use. Like so many people, 50 to 100 or more in villages, they use that water for their purpose. So that was just a curiosity. No, thank you so much.
Yes, thank you, madam. Thank you.
No, in fact, I will also congratulate Susama for the type of work that she has done at Koraput and presently also doing at IIRI. And as she mentioned, I have personally seen the impact of that particular project. And now many Jhola kundis are available in the areas. Actually, people are encouraged to have such type of water harvesting structures, and they are also using for irrigation in that area. And Susma, very nice presentation. I'm really proud of you.
Thank you, sir. Thank you.
Hello.
Hello. Yes.
Sir. Sir.
Sir.
Ke Prabhatavu? Ke Narendra?
Sir.
Narendra, go ahead. Go ahead.
One clarification I want from Dr. Susama.
Sir.
Dr. Susama, you have written one line in that your PowerPoint. What is the wrong construction in Hirakud Dam? You have written one line in Hirakud Dam, that part. And also I want to know, I am now working as Executive Engineer Soil Conservation Southern Zone, Barampur. 10 districts are under me. So in which block you have constructed the Jhola kundi so that I will go and also see to gain some experience?
Similiguda, sir.
Similiguda, yes.
Yes, sir.
I will be going perhaps next week or after that week.
Yes, sir.
Similiguda.
So if you'll go to sir, the regional station, sir, Central Soil and Water Conservation.
Yeah, I had been to there once. That
Yes,
for that reward project is going on. Reward project, one project of Soil Conservation Department is going in some watershed areas. I had been once to that institute also.
So there, after coming from that year, one scientist is Jyoti Das, sir. So
yeah,
Jyoti Das also and other people, they have constructed so many Jhola kundis in that area.
Yeah.
And also farmers are doing, and BDO of that area also they have taken the most interest, and they have constructed so many Jhola kundis in that area.
Similiguda. Yes, one of our agriculture engineers is there at as ADSC perhaps there. I know.
Sir, Similiguda, Koraput and Potangi.
Potangi, yes. That line, that
Yes,
Devamari line.
Yes, sir.
What tangi
Because
that Deomari
in
line?
that area, Jhola lands are more, no, sir? Perennial source.
Acha. And another that I asked to you, what is the wrong construction in Hirakud Dam?
Sir, I am not remembering. Here it
Yes,
is.
one.
Sorry, sir.
Actually,
Line was there.
Narendra, Debashish Patti has volunteered to speak about or throw some light on design failures of Hirakud Dam.
No, I am not volunteer. That is a typological error. I have corrected it. Can anybody throw some light on the design? Because one of the reputed and established engineer, the engineer Biseswaraj, was one of the design engineer. So what is the design faults or errors analyzed in the current scenario? That I was trying to ask.
Yes. Sir, mତେ କାଇଁ ଭୟ ଲାଗୁଛି ମୁଁ ସେ ଏରିଆ ଲୋକ ତ କେତେବେଳେ ଭାଙ୍ଗି ଯିବ ଯେ ଆମେ ବୁଡି ଯିବ ଆମ ଘର ଦ୍ୱାର ସବୁ ସେଥିପାଇଁ ମୁଁ ପଚାରୁଛି
Hello. Chance nine.
Hello.
And DK Das. Okay, just I am interacting. There was this question.
Sir.
The design is well taken and it is approved by so many organizations. That is, and we have dam safety organization as well as they are checking every year. They have some questionnaires. They have some examinations. All the dams. There are some cracks that has been also prepared. Now new cracks are also developing. There is no chance of collapsing. It is losing its life storage because of siltation, heavy siltation. Though soil conservation department has taken catchment treatment plants, but a lot of constructions are going on. And there are the danger is that flood control is not able to controlled by our officers, as Chhattisgarh is having a lot of barrages and they are not informing and releasing a lot of flood water. That is creating problem for us. Otherwise, it is very safe, so to say, and sustaining for the last 70 years. That's all. Thank you.
Thank you.
Yes. Thank you, sir.
I have something to speak.
Yes, sir.
Regarding that Hirakud Dam. Actually, all the major dams that is constructed for a life period of 100 years all over the world, they take it into consideration that it is for 100 years. So our Hirakud Dam was completed in the year, I think, 57. So it is already 65 years, above 65 years. So the second thing what Susama was telling, to desilt the Hirakud Dam. Desiltation is done in small ponds or reservoirs like the soil conservation ponds or minor irrigation reservoirs, but not in such large reservoir like Hirakud or major reservoirs of India. Then the third problem that Susama has not told, now the irrigation department, they say, if we desilt the Hirakud Dam, then we will get the siltation of quantity, silt of quantity 1 kilometer into 1 kilometer into 1 meter, where they will put the silt. That is the another problem. As the first problem is where to keep the water and how to safely discharge the water. And the second problem is where to keep so much of silt, in which place, in which site near Sambalpur. That is another problem. That to be taken into consideration. Thank you.
Actually, the siltation problem also relates to Chhattisgarh. And Chhattisgarh, they don't take any conservation measures, for which we have more siltation in Hirakud. Okay, and it's a interboundary politics that we cannot win easily. So, is that right, Susama?
Yes, sir. So what Prabhat sir told about the siltation, what I told, if it will be done siltation, it will take minimum 4 to 5 years. So, but that is not the solution, what I emphasize. But if you will do the what he told, that is very much correct. Where to keep those silt, if it will be desilted. And again, the problem is where to divert the water. So in case of these dams, this is the main problem, what to be done and how to restore. But in small reservoirs and other things, that can be done. There is a possibility, but for bigger dams and where the dams located in under the earthquake zone, so that is the main problem also. Because what I told in Tehri Dam, if any day, if the magnitude of earthquake will be more than 10, then there will be whole Uttarakhand, Uttar Pradesh and Delhi, it will be affected.
So with this, thank you, Susama. With this, I would like to conclude now because we are past 5 minutes also. But we can take more questions through this through the WhatsApp groups where we can converse with you more. I hope when you find time from your Jhola kundis. And a lot of people have congratulated you on the chat body. So I'm not going to take individual names, but everybody thought it was a great presentation, and I really am happy that we got you to present to us the issues, real issues of dams and reservoirs and water bodies and wetlands, which are wetlands is another issue that we didn't discuss much today, but that's another big issue that the whole world will face, which will come back later too. Maybe somebody else can present on wetlands. But again, thank you very much for all the great work you are doing. Keep it up. And this is an area which many agricultural engineers do not engage in. And I'm glad that you have engaged in, and you are throwing some light towards this area. So thank you very much for the presentation today. Okay.
Thank you, sir, for giving me this opportunity, and I can see all my teachers.
Yes.
Their face through this. Thank you very much, sir.
So we'll see you next month with another woman engineer making a presentation. I hope all of you can join. Biswajit, what's her name? I'm forgetting.
Winnie Rautra, sir.
Oh, Winnie Rautra. Okay. Winnie Rautra is going to present on her food food challenges or whatever. I don't know yet. Waste challenges. Okay. So if you all can join, we can make this interaction more active, and we can learn more from each other. That's the whole idea of this tea talks. Once a month, we can spare 1 hour, right? Right, Durjadhan, you should be here every tea talk from now onwards. Okay. All right. All of you have a good evening, and see you next month.
Thank you.
Okay?
Thank you.
Johar, sir.
Yeah, Johar. Okay.
Thank
Bye.
you, Dr. Susama. Many thanks to you.
Thank you.
Yes. नरेंद्र तमे जाइके देखि के आसो झोला कुंडी
आगे मु जीबी सर एबे जाइथिली फेरिछि किंतु मु जानिनी एते जिंसो से आगे जाई
फोटो उठै क्रमश पठैबो
हां से पठेबी ना सर बाटरे जाउ जो क्रमश रे निश्चय जीवन हेता देवमाली फेमाली जाइछि एगुडा को मु जानिनी बोली जाइनी सियाडे एबे जीबी ऑफिशियल टूर रे सर
ओके ऑल राइट ओके बाय
नमस्कार
थैंक यू
नमस्कार